Okay, ears, eyes. Um, so mess up on my part yesterday, or actually 2 days ago when I assigned it, I only assigned half of the assignment. So I sent out last night that I assigned the other part. Let's talk. This is uh-oh on me, not necessarily you. If you didn't complete it, don't worry about it. I'll put your 5 points in. What my recommendation is to you is to at least look at it, especially the multiple choice ones. Okay, look at those. So I'm going to put your 5 points in for completing the 6 questions. A lot of you guys went back and finished all of it, and I appreciate that. It was a uh-oh on my part. They split up the assignments, and I didn't realize it. I just see the recommended assignment. I didn't see a recommended number 2 assignment. So that was the story on me putting those last 10 questions in. Okay. So don't worry about your assignment. Don't worry about your grades on that part of it. However, like I said, I do think it's going to be advantageous you to go back. This one will close. In fact, it already closed, I think, but I'll have the makeup one. And so just look at the makeup one, and I recommend looking at the multiple choice questions, okay? Because that's what you're going to kind of see. And if you have a tough time with those multiple choice, you may go back and look at some of the other questions, okay? They do go in order. I did find out for sure, like 1, 3, 5, 7, 9. It's the odds that are assigned. And so what's nice is number 9 is number 9 in your book. And so if by some crazy chance you get stuck on one, I do recommend going to your book because the book does have videos explaining some of the questions, not all of them, but some of them. And so that may help you to better understand. Okay, everybody okay with the assignment? So I can't tell you what was most missed because after I signed it, it jacked everything up and it looked like nobody completed it and everybody did. And so anyway, big day today. Big day today. A lot of talking. Probably too much note taking, but I'm trying to emphasize the main things you need to know as we're going through it. We're going to cover a lot of things. Most of the stuff you know. Most of this stuff you know, but I got to make sure you know it well enough for AP. So I am recording your class today because I forgot to record this morning's. Just be aware of that as we're going through it. Don't say something really, really, really stupid. But if you have questions, please ask. Please. You will also know that as I'm going through this, that your notes will kind of get skipped over some things. Just kind of understand I'm skipping over the stuff I'm assuming you already really know. So here's our goal today. Got learning targets. We got several of them. The first thing, once it goes, we're going to find the median of a distribution. I don't think I need to teach you anything. However, I want to make sure that you understand a couple of terminology. We're going to calculate the mean of a distribution. Same thing. I think you guys know that. I'm going to give you some notation and I'm going to give you some formulas. Find the range of a distribution. I think most of you guys know how to find the range. I am concerned because some students do say the wrong thing on the range. We're going to calculate and interpret the standard deviation. And if you don't get anything today, we got to make sure we get the distribution. The interpretation. Sorry. Turn that back off. There you are. We got to get the interpretation of the standard deviation. Whoop. Dang it. Oh, there you go. Okay. Interpretation. Calculation. I'm going to show you how to calculate all that stuff. I'm not sure how big of a deal it is. Manually. Find the interquartile range. And then choose the appropriate measure of the center and the spread. So 6 things we got to cover today. I think you're good. I think you're good. You're probably not. You're probably not. Probably not. Yay? Click. Median. Median. I don't have to say much about the median. You guys know the median is the middle number. And that's doesn't change. It is the middle number. It's now, it's not, it's the average of the middle numbers if it's an even set. Okay. But section 1, we advise you to use the middle value in order to that data set to define its center. That's the median. Okay. So we know the median is the midpoint, it's that middle value, nothing's different. Let me say this just to make sure you understand. If that's the median, 50% of the data is to the left and 50% of the data is to the right. It divides it into 50% and 50%. Sometimes percentiles are a little bit important in statistics, so we'll divide that up that way. Just, I mean, you know that, but I just want to make sure that makes it understood. Okay, so median. I don't know how much of that you need. Like I said, there's no symbol for median. The median is just the median. It's just that number. If it's an odd number, it's the middle one. If it's an even one, it's the average of those two. If it's odd, there's that part. If it's even, there's that part. You can find the medians by hand, by small sets of data. I don't know how much of that you need to write, guys. I really firmly believe that I know the Algebra 2 kids or the Algebra 2 teachers, as well as geometry, I think at some point, but probably even elementary school or middle school, junior high, somewhere in there, you talked about medians, I think, before you came to this class. And it's the same, it's that value. It's that value. So I'm going to stop here and wait for everybody to do a little catch up. When I see a bunch of pencils stop, we'll keep going. You're here, you guys, it's always you two, you three. Somebody gone? Was it? Porter? I got your buddy in classroom. Yeah. Anybody else? Emma? I like to check roll that way sometimes. Y'all will have to help me though, because I don't know Porter or Emma. I'm learning. Not real good. I did a lot better back in the day when you guys would turn in homework and I would grade it and I would say the name and put it in the grade, and then I got to hand it back out. So I got to put a name with a face. And because I don't do that now, it takes forever to learn your names. But I told you after about 3 or 4 or 5, 6 months, I'll get it down, maybe. But some of my students from last year come up to me and say, it's bad. I've got too many things. 30 years. That's a lot of kids. Pencils. Click, click. Fiddler crabs feeding, scooping, they food, scoop in their mouth. Researchers observed one species of fiddler crabs, the Yucca perleca, in a park in Indonesia. Here are the feeding rates per 30 seconds. So here they are right over here. I do want to make sure we do understand this, right? The first thing we got to do if we're doing this by hand is put the numbers in order, right? So do make sure we do that. That is one thing that ACT tries to get you to do, right? So we'll put those numbers in order. We'll put them in order. We know that there's 30 of those there's 20 of them. So there's 20 of them. So we got to look at the 10th and the 11th number. And so we'll look at the 10th and 11th number, which is 58 and 59, and we'll figure out the average of those two, which it doesn't take a whole lot of math to realize that that's 58.5. Of course, we would love to put the context of it. Okay. We would love to put the context of it. So 58.5. Easy peasy. Most of the time, they are going to give you the median. You're not going to have to find it. You finding the median says nothing about your AP statistical knowledge. It says you understand how to do it, but I can ask questions about it just as easy. Okay? Questions. Good, 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 good. Median. Median, median. And nothing's different. Nothing's new. Mean. Nothing's new. I know some of you guys didn't get done with that, but don't write too much. Mean. You already know the mean. Mean is simply the average. Average. Add them all up, divide by how many you got, right? The most common use of measure of center, we use the mean more than we use the median. Why? Just because it typically gives us a little bit better number, right? But it's just, you know what the mean is. You know it is. It's nothing different. The distribution of quantitative data and all market data, to find the mean, you add them all up and you divide by the number of data points. Write down what you need to. I'm going to make sure that we'll write down some things in just a second. Boom. Okay, write down what you need to, and I'm getting ready to give you a formula that you may or may not see, but I want to make sure you know how to read it. Okay, so we'll talk about X bar, we'll talk about N in just a second. Here we go, let's go. Mean has a symbol. Mean has a symbol. And it depends on if we're talking about the mean of the sample or the mean of the population. They're two different symbols. So, X bar, X bar. Now, do picture yourself taking the AP exam coming in May, and at some point you may have to have an X bar, and you're typing stuff, and it's hard to find an X bar on the keyboard, or it's hard to maybe find there may be a drop down. Something. If all that's become X BAR, you can say it. Y'all okay with what I'm saying? X BAR, and just write it out. It's okay. They're not going to ding you because you didn't put the actual symbol. So X bar, okay? Sum of the data. Now here's the formula that's actually on your formula sheet. Again, I don't think you'll ever use it. But they're going to put XI, X sub I. So that's test score 1, test score 2, test score 3, test score 4. And then they're going to put this Greek letter right here, which is a big old sigma symbol. And it means summation. That means summation. You may or may not have seen that in your mathematical career. So you are adding up all the X values. You're adding up all the test scores. And then you're going to divide it by N, and you already know what N is. We told that one the other day. That's your sample size. That's the number of test scores. And so that's a formula you're going to have on your formula sheet. I don't think you'll ever use it because it says nothing about your mathematical. It says something about your mathematical knowledge. It says nothing about your AP knowledge, AP statistic knowledge. Okay? So more times than not, they're going to give you the value. They're going to give you the value. The mean does not split it up into 50%, 50%. It finds the average of the middle. That's not 50%, 50%. Okay? Do you understand that? X bar. Now, I think it's my next slide or the next slide. I went through these slides. I was telling the first class. I think I went through them 16 times. It started yesterday. And I went through them. And I'd fix it. And I'd go through them. And I'd do something else. And I'd go through them. And I said, all right, the time that I quit doing something is when I'm satisfied. And about 11:30 last night, I said, I'm done. So I kept changing something every time. So I didn't know for sure when I wanted to talk about the population average. But that's a Greek symbol, mu, M-U, said, pronounced mu. Greek symbol. It just looks like a fancy U, maybe half of a W or 3/4 of a W. Again, you don't have that typing it. So if you just type in MU, right? I think you're going to have drop downs, like a little symbol key, if you need it. Okay, but that's the population mean, of which we hardly ever know. If we know that, then we don't need to do anything. We're going to use the sample mean. Sometimes they're going to tell us what they think the population mean is. And of course, we'll have a sample and we'll compare those two. That's all future stuff, no big deal. But I just kind of want to get you a little familiar with some notation. Okay, Greek letter mu means the population average. This is the sample average. Most of the time, you're going to be using X bar because we're not dealing with the populations, we're dealing with the samples. Next semester, they're going to tell us what they think this is. And so we're going to compare this to this and know that they're not going to be the same thing. Uh-oh. What do you need?
I can't get it to link and work. Will you give that a try if you get a chance to
Yeah.
update the operating system?
Okay.
It just is frozen.
Okay. All right. What else you got? Good? Mean. Well, what else I have up here? There's the Greek letter sigma. The formula is short for add them all up. Oh, and here's where the mu is. Okay. We need to refer the population mean. We'll use the symbol mu. There it is, typed, so you can kind of see what it is, how you write it. We're not, like I said, there is no way for you guys to mess that up writing it. And that's all you're concerned with right now is writing it for me. There's no way that you can mess this up. Well, I meant this. No, you didn't. I mean, you can put pretty much whatever you want right here, and whatever. If you put a bar above it, now I'm really confused. Now I'm confused now. Y'all okay with all that, right? Click, click, click. Just practice writing mu a couple of times. You'll be good. You should never have to write. Boom, 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 boom. Pencils, 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 pencils. Some pencils are going. Who has a question? Median and mean. Notation. Notation is new. The symbol X bar is a sample statistic. Remember the words statistic and parameter, right? It's the number that's associated with a sample is a statistic, and the number that's associated with the population is a parameter. That doesn't change. Remember those words, statistic, parameters. We haven't dealt a whole lot with statistics and parameters. We've talked about samples and the populations, but the statistic and the parameter is the number that describes those. Okay? So X bar is a sample statistic. The mean is this, 27.6. The mean of the population is a parameter, 30. Okay. Yippee, yippee, yo. Everybody's okay on their homework last night, right? Y'all okay with it? Y'all I don't ever feel pressure, but I don't try to do homework as busy work, but I felt like I didn't give you guys, because I didn't get those multiple choices. That's why I assigned it. It had nothing to do with anything else. Click. Truthfully, I probably should have assigned the second part before the first part. You probably didn't need the first part. Here's those fiddler crabs again. Scooping up the food in their mouth. Research observed species. Those are the 20, whatever they are. The feeding rates per 30 seconds. Calculate the mean. And so the mean, you would simply add up those, whatever, 20 numbers, 30 numbers, 20 numbers, 20 numbers. Add up those 20 numbers and divide by 20, and we would be done. Okay? I'm actually going to show you an easier way how to do this in your calculator than to actually hit plus, 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 and divide by and hit enter. Okay? I'll show you a little bit easier way how to do this in your calculator. So you would add all those things up, you divide by 20, you're going to get 55.5 scoops per 30 seconds. Again, please put the context afterwards. Okay, if you just put the 55.5, I don't necessarily know exactly what you're talking about. They always expect something written with it, right? So those teachers way back in the day when you forgot to put like feet per second or feet squared, or you forgot to put your units of measurement, and they took off, AP is going to do the same thing. Question about that? Good, mean, average. Several of y'all are writing that down. You're in a really bad spot, I know. Y'all slowly get moved up, and as you get moved up, this angle gets really bad here. So Monday I'll move everybody back some. When they come through and sweep, they push them forward, and they just keep pushing them forward. Push them forward, then push them back. I appreciate them sweeping. That's awful nice. Click. The researchers excluded one crab. So here we go, starting to learn a little bit something. Again, you guys are freaking smart. You'll figure this out. They excluded a crab, usually feeding high at a rate of 127. Holy cow. Per 30 seconds. Calculate the mean feeding rate for all 21 crabs. So we had 20, there's actually 21. The 21st feeds at 127. Again, let's see how brilliant you guys are. If I put 127 with all those things right there, that's going to do what to the mean? Oh, I love teaching AP kids. Golly. I get nervous sometimes. You guys are so smart. So if I add the 127 out there and divide it by 21, I'm going to get 58.9 scoops per 30 seconds. 58.9. Got a dog request. I babysit dogs on the side. Let's see what we got. Let's see what we got. Oh, jeepers! Wrote a novel. Can't see. Frank. German Shepherd, who was abandoned. One year, 7 months old. 25th of August. Okay. I'll have to accept later. A little too busy. I get requests all the time. I got a 5-star rating. Pretty cool. Well, when my doggy passed away, we decided, my kids are almost gone. I just got rid of my kids. Why do I want another one? But I love dogs. So people come and drop their dog off. I take care of their dog and I come by and pick them up. Pretty good gig. And I can turn it off like all summer. Nope, busy. Nope, busy. Nope, busy. And if they got a little bitty piece of crap dog, I typically say nope. Because I like big dogs. Okay. Sorry, 127. Side note. I'm trying to be in a hurry here, right? What did we notice? Again, beautiful. It went up. You add something bigger, it's going to have to bring the average up, right? The average was 55.5. The average now is 58.9. So it actually raised, 3.4 scoops per 30 seconds. Again, I'm not telling you anything you don't know, but I do want you to recognize a couple of things, okay? And right now, what we're getting ready to talk about is I'm getting ready to throw a word out that you probably have not heard before, at least not used in a statistics class, because this will be your first statistics class. So what they're going to say is this: the mean is not resistant. It's not resistant. So let me give you that definition of resistant, okay? Resistant. It's a statistical measure is resistant. It is resistant if it's not affected by an outlier. It's not affected by something really extreme. So write what you need to on that, and then we're going to talk, and I'll put things in perspective for you guys. The mean is not resistant. When I put that 127 out there, it moved the average 3.49, whatever, 3.4, thank you. Moved it 3.4. Think about this. I put that 127 out there, what's it going to do to the median? I mean, if it moves it, it's going to move it just to that next one. And really, I don't mean like it puts it out there. Let's just say it removes one of those and puts it out there. It's going to actually stay the same. So the median is resistant because it's not affected by outliers. Because, well, what if I put 6 of them out there? Well, you put 6 of them out there, the median was not there. The median was out here, and it's still not moved. Resistant. There's statistics. Listen to my terminology again. Statistics, number that describes a sample, that are affected by outliers and are not. And the mean is affected by it. The median is not. Therefore, the median is resistant and the mean is not. Terminology you got to make sure you know. Which of the following statistics are resistant? Which of the following are not resistant? Two different types of multiple choice type questions we can ask. Test A will probably have one, and B will have another. Click, 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 click. All right, so right here, this was before the 127, right? These are all my dots right here, and that mean was 55.5. When I put that 127 way out there, it jumped up from the 55.5 to the 58.9. It didn't move a whole lot, but it moved. Whereas the median would have gone from that blue dot to in between those two blue dots. It's not going to change. It's not going to change. Now, by some crazy chance, I guess, if one dot was here and the next dot was there, it would change quite a bit, but just kind of play along with what I'm talking about. Everybody okay with those terminology? Median, mean, those numbers you should be good with. X bar you should be good with. That's new. Mu, so mu and X bar, now resistant. Okay? Terminology we got to somewhat get wrapped around, especially by a week ago or a week from Tuesday. Click. Comparing the mean and the median. We're going to compare the mean and the median just quickly because both of those are measures of center. Both of those are measures of center. One of them's better than the other one, but they both measure center. The relationship between the mean and the median depends on the shape of the distribution and whether or not there are outliers or not. Okay, so we need to look at the shape of the distribution, and that's going to help us compare the mean and the median. So if a distribution of quantitative data is roughly symmetric, there's that roughly symmetric, okay? The mean and the median are going to be roughly the same. They're going to be similar. If the shape is symmetric, the mean and the median will be similar. They will be close. Here's a symmetric distribution. Of course, I got a couple of extras down here. I got one pretty good way up there, but the median of that data is 23.05, and the mean is 22.96. They're really close to each other. Don't say they're going to be the same. They're going to be close. They're going to be similar. If it's symmetric. If it's symmetric. Now, brilliant young AP students, I'm going to take and add several dots down this way down here. That's now going to make this skew to the left. I'm going to add them down here. Oh, I got you. Y'all better than me. I'm trying to ask for a right answer. I don't want to add them all. If I add them all right there, then no, I'll be screwed right. I'm going to put a couple of them out here. Move those here. Skew it. It's going to have to do what? Median's going to stay somewhere around in this still area, but it's got to have to pull the average. Got to pull the average. If the distribution is skewed, the mean is going to get pulled in the skewness. This one is skewed to the left. Okay. It has to pull the average down. I think we can actually see, I can start counting and figure out the median. I bet my median is somewhere, in fact, it looks like it's highlighted. It's probably somewhere around that 19, but if anything, it's around that 18. It could be between that 18 and that 19, but it's probably closer to that 19. But all these numbers way down here have got to pull that mean. It's got to pull that mean. Okay? The median is 19. The mean is 17.87. Not a whole lot different, but it's different. It's not 0.06 different like it was last time. Okay, skew to the left has to pull the mean lower. Skew to the right has to pull the mean higher. The median stays pretty close to the middle set of the data. It's 50%, 50%. It actually teeter-totters there. It actually teeter-totters at that median, 50%, 50%. The mean, that's where we gotta make it sure we get it, pull it. Okay, it's gonna pull it. Boom, here's a skew to the right, so that means that mean has to be higher than the median. Most of you guys have stopped writing. Now listen to this, okay? This is where some students mess up, so I'm giving you a heads up. Proofs, I know this has nothing to do with a proof, but some of you have dealt with proofs before in geometry, right? And there's an if and only if. And if it's an if and only if, then that means if this happens, then this happens. And if this happens, this happens. This is not an if and only if. If the data is skewed, that has to pull the mean. If the mean and the median are different, so the mean is higher, it does not mean it's skewed. So be careful of that, okay? Just because the mean is more than the median, it does not make it skewed. If it's skewed, this has to happen. But if this happens, this does not have to happen. Okay, just kind of make sure you're aware of that. Be careful. It's hard to go back to shapes. You can go from shapes to numbers. It's hard to go from numbers to shapes. Because I can draw one where the mean is higher than the median that does not skew to the right. Okay. You had something. You good? You got it? Good? Everybody else? Happy, happy, joy, joy? Anything about that? Everybody okay with the mean? I think we're done with the mean. Boom. Oh, there's the median is 3. Now the mean is 4.14. Okay, because it's skewed. It's going to pull it. All right. Yes, sir. Yes, sir. Woo! And I don't have sugar, and I don't do caffeine. What did you say? She just said that? Oh, yeah, I can't have sugar. There's no way. How would I act with sugar?
We should test that out.
No! I already have a tough time sleeping.
You'll just cry.
Shh. Variability. Okay, so we've talked about the center. We use the mean and the median for center, right? We talked about the shape yesterday. Shape yesterday, center today. Now we're getting ready to talk about the variability and or the spread. Okay? The first thing we're going to talk about is standard deviation. So look at this right here. Being able to describe the shape and the center of a distribution of a quantitative data is a great start. It tells us a whole lot if you give us the shape and the center. However, two distinctions can have the same shape and the center, but still not look the same. Look at the parallel box plots of the length of times of random samples of PVC pipe from two different suppliers. So here we go, we have supplier A and supplier B. And both of those are what? Symmetric. I'm going to tell you that they both have the same center at 600, but they are completely different data. That one on the left or your right-hand side is a whole lot more varied. It varies a whole lot more than this one right here. It's a whole lot more tightly knit. It doesn't vary as much. This one is, can I say, more accurate, more precise, and that one's a whole lot more randomness, less like the bad tape measure. I don't know. Y'all okay with that? So shape, center are two things we got to use, and then we also have to talk about the spread because that describes the data. And it's hard to describe it with other things other than that, other than maybe an outlier and those other gaps. Both distributions are roughly symmetric, unimodal, single-spaced, centers at 600, but the variability is completely different. There are several ways to measure the variability. Several ways to measure variability. The simplest is the range. The simplest is the range. And the range is simply, come on, the max minus the min. It's the max minus the min. Did I put the other one? I've lost one of them again. Oh, that's disappointing. I made it through a pretty good way without losing one. Let it show up. It's a max minus the min. Some students mess up. They'll say from 4 to 8 is the range. Nope. The range is a single number. It's not 4 to 8. The range is 4. It's the max minus the min. You don't want to do min minus the max, because if you do min minus the max, you're going to get a negative. And there's no such thing as a negative distance, because the range is a distance. That's how far apart the two values are. Easiest, most simple thing to do. It doesn't always help us a whole lot. However, it would have helped us here a little bit, because the range of this one is from 601.5 to whatever that subtraction is, and that one over there is quite a bit bigger range. Clicky, click, 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 click. Oh, there it is. The range of a data set is a single number. That is one of the few things I will see students mess up on. The range is from here to here. No, the range is. The values go from here to here. You can say that. Just don't say that's the range. The minimum value is this and the maximum value is this. You can say that. You just can't say that's the range. The range is a single number. Click, good, happy. Boom, boom. In a recent year, Consumer Reports reviewed rated 14 different mid-size SUVs. Here are the distances in feet of each vehicle needed to become a completely stop from a speed of 60 miles per hour. There they are. I can figure out the median, I can figure out the mean, and I can figure out the range now. They want me to find the range. So I could quickly find the biggest number over there. I'll give you a hint, it's 149. And I need the minimum number, which I can quickly circle is 126. And then I can subtract 149 and 126. And 149 minus 26 is simply 23. And we want to put the feet because that is the unit of measurement. Because it said in feet. It will always tell you what it's in. Median, mean, range. X bar, mu, resistant. You're probably good on 2 of those before you came here, and you're probably, half of you are probably okay on range. My concept is, I know in 9th grade or in 8th grade, 7th grade, when I taught range, we just always said it's from 6 to 12. We said that. I was wrong. It's not from 6 to 12, it's 6. It's a single number. No pencils are going. We're good. Click. Is the range resistant to, is a resistant measure of variability? If I add an outlier, is that going to change the range? So is it resistant? No, that always confuses me. Resistant to me meant like it wouldn't change. It does change. Okay, whatever. Everybody okay with that? Good? All right, beautiful. It's not resistant measure of variability because it can change. All right. Why is the range not an ideal way of measuring variability? I mean, you may or may not understand this, but the range doesn't necessarily tell me how it's grouped around the middle. I can have a really big group around the middle and still have 2 outpoints right here, or I can be really spread out and have 2 outposts. So the range really doesn't tell us how far the values are from the mean. And that really tells us our spread. I mean, the range is not wrong. It's just not a good one. It's kind of like the mode. I mean, the mode isn't really wrong. It's just not a good one. It doesn't really tell us a whole lot about the center. The range, it tells us how the minimum and the maximum and how far apart they are. And if I know what the middle is, maybe that helps. But it's not always the greatest unit of measurement. One of my last slides will say, use the range as a last resort. Use the range as a last resort. All right, click. Oh, here's two sets of, here's a great example, right? Both of them have the exact same minimum and the maximum. This one actually is a whole lot more consistent than this one at the bottom, because the middle is 70 for both of them. But the bottom one has a whole lot more variation from the middle than the top one. They're both symmetric. They both have centers at 70, and they both have ranges of the same value. But I don't think they both tell me the same story. Beautiful. Okay. Standard deviation. Heard of it? Anybody? Heard a little bit? Good. Okay. If you don't know it after today, or you don't know it Tuesday from now, woo, bad score on test. If we summarize the center of the distribution with a mean, then we should use standard deviation. Mean and standard deviation kind of go together. Mean and standard deviation kind of go together. If you use the mean, you should use the standard deviation. Okay? Here's the definition of the standard deviation. Again, I told you guys you don't have to necessarily know definitions. However, if you know this one, it's going to help you. The standard deviation measures the typical distance, the average distance, the typical distance. I don't know how else you can say it other than those two words. You guys' thesaurus is probably a little bit bigger than mine, but typical or average has to be one of those words. Distance from the mean. From the mean. It's the average distance from the mean. Average distance from the mean. It's calculated by finding the average of the square root of the deviations. This doesn't mean nothing to you right now, and I'm not going to emphasize that. Average distance, or the typical distance from the mean. Here's the formula for it. Whoops, come on. Right there. It looks horrendous. S. That's the variable you're going to use for the standard deviation. A lot of times the book will use a little subscript of X. You can put it or not. You can put it or not. Uh-oh, now what? Coach Mayer. Sure. Okie dokie, on our way. Uh-huh. Shael? That's what I thought. I thought that was right. But y'all heard me say sure. I didn't know who Shael was. Y'all impressed I can answer my phone? That way I don't have to be in my room and they think I am. I just leave. And I can turn it off after I leave, because I'm not supposed to be in my room. But I don't. All right. Sub X. You'll see a sub X a lot of times. Put it there or don't. I don't really care. And then you got this equal sign, okay? And then you got this radical looking thing. It's really radical. It's a radical. I don't know. Hey, we're getting ready to show you a little bit of math. Yeah. You got this stupid looking E looking thing, which we already know means add them up, sum them up, summation. We got a parentheses and we have an X sub I, which you already know is like your test score. 60, 70, 70, 70, 60, 50, 80, right? We're going to subtract X bar, which now you know X bar is the mean. And then we're going to square those stupid things. And actually, we're going to do it in order of operations. We're going to do X minus X bar and then square and then add them up. And then we're going to divide this because we're finding the average of n minus 1. Bear with me. This formula is on the formula sheet. I didn't tell you that about mean. That formula is on the formula sheet. Means and standard deviation formula is on the formula sheet, and I don't think you'll ever use it. But it's there if you need it. I do think it's very important that you understand how this works. Yes, your calculator will find it. Yes, a computer will find it. Yes, a program will find it very, very easily. But I think it's important that you understand how this works. Okay? So let's talk about this formula and how it works. Okay? That's important. Whoops, I moved this and now I can't want to walk over there. Why are you not? Oh, that's what I got hit. The value obtained before taking the square root of the standard deviation is called the sample variance. Okay, that's important for you to know. That's a terminology that you probably have not heard before. And it's the value before you take the square root. And look, ooh, here's the mathematical, huh? It's denoted by s squared. Because s squared will equal the summation of x minus x bar squared over n minus 1. That's what s squared equals. If I take the square root of both sides, then I will have s equals the square root of that. Just kind of soak that in for just a little bit. I don't think it's going to keep you from passing the AP exam. However, I do think it's very important to understand the concept of it. Click. When loose granular materials like sand or asphalt is piled on the ground, the side of the pile forms an angle to the ground horizontal plane called the angle of repose. Each material has its own angle of repose, and the angle of repose in degrees for 6 randomly selected materials are shown here. So we only have 6 of these materials. There's the 6 materials. Soaking that up, okay? Calculate the standard deviation. Well, in order to calculate the standard deviation, class, first thing you have to do is find the average, because the average was x minus x bar. You got to know what x bar is. And so x bar, we're going to add those 6 numbers up and we're going to divide by 6, and I'll go ahead and cheat and tell you that's 38.5. So x bar is 38.5. Okay? Now you have to do x minus x bar. So let me do this. 33 minus 38.5, and that's equal to negative 5.5. Let me stop there. That is called a deviation. The standard deviation is the average of the deviations from the mean. That's a deviation. Okay? Yep. Nope.
Where did you get 33 from?
Oh, I'm sorry. It's okay. It's not a dumb question if you don't know. Dumb question. Can I go to the bathroom? That's a dumb question. Can I sharpen my pencil? Dumb question. Can I walk? Dumb question. Where did 33 come from? Not a dumb question. Yeah. I'm getting ready to use the rest of them. I got to use all of them. I'm getting ready to use all of them. That's why you're asking questions. See, you're doing so good. Boom! I don't need sugar. Don't do drugs. Don't no need to. I'm high on life. Woohoo! Okay. I'm getting ready to do all these. Getting ready to do all these. Okay. So, sorry. I should do more of those. I should do rest of them and then do it. So I'll learn that next time. I'll do rest of them and then I'll talk about it being a deviation. Okay. Good. So negative 5.5 is a deviation. Yes, you can have negative deviations. Yes, you will have positive deviations. Okay, so let's do the next one. Make me happier, make y'all happier, maybe. 45 minus 38.5. 76.5. Now I'll stop. Y'all okay? So this is a negative deviation. This is a positive deviation. Tell me this. What does a positive deviation tell you? The value, not above, it's above. The value is above the mean. If it's a negative deviation, it has to be below the mean. That's important to kind of somewhat recognize things that you would think are common sense. However, we want to make sure we emphasize the common sense things. So here I go with the rest of these things real quick. Let me do 28 minus 38.5. I'm going to go ahead and do each one of these. I've did it on the next page. Let me do that. Boom. There's the subtraction of each one of those. Okay. Let y'all catch up for just a second. Let y'all catch up for just a second. Again, notice that I have some negative deviations. Notice that I have some positive deviations. There will always be negatives and there will always be positives. There won't always be equal number of negatives and equal number of positives. But there will always be negatives and always be positives. So when we get to a good point, we're going to get to a good point, and then I got to have you guys watch and look and learn, because again, this is a big, big, big deal. Okay? This is kind of a big deal. This is like this is kind of cool. Somebody came up with this somewhere. Okay, so if we want to take the average of something, you guys know this, right? To find the average, what we have to do? Add them all up and divide by that, right? Well, guess what? If you add all this up, you're going to get 0. Not this time, not next time, every time. Unless you got the mean wrong, because you're really kind of undoing the mean. Mathematically speaking, you added them all up and divided by it to get this number. And then if I subtract this number from half these right here and add it, you're going to get 0 every time. It's a proof. It's an easy proof. So you can't find the average if you add this up and get 0, because you're going to divide by whatever and you're still going to get 0. And that means there's no deviation, and that's not true. So somebody decided we're going to square those things. Why? I don't know. That's what they decided to do. I always get some students say, why didn't they take the absolute value? That's a good idea. I don't know why they didn't do that. They could have. Somebody did. But that's not the standard deviation. That's the absolute value deviation. And we don't deal with absolute value deviation in AP statistics. We only deal with the standard deviation. Also, because this, if I square everything, I can undo a square. By taking the square root, you can't undo an absolute value. If you do an absolute value, you do an absolute value, and there's no undoing of an absolute value. So they're going to square every of these values right here, right? Think about my formula. It's x minus x bar squared. This is x minus x bar. This is squared. Now these numbers are starting to get pretty big. Is what it is. Now what do I got to do to all these bad boys? Add them up. Because it was the summation of x minus x bar squared. Again, if you don't get this, you're going to be okay. But I just think it's one of those, man, this kind of really solidifies why we're doing what we're doing. I mean, I used to ask, why do we square the deviations? I used to ask that on a test question. Well, you have to do something, because if you don't, it's going to get 0. So we square all those bad boys, and then some knucklehead decided, I don't want to divide that by n. I want to divide it by n minus 1. Why? AI. Why do they divide by n minus 1 and not n? It's to account for some variability that may or may not happen, right? Remember, this is a sample. So you're going to divide by n minus 1, and that's because somebody a whole lot smarter than me decided that's what they're going to do. So you divide that by n minus 1, and you're going to have this number right here, right? Y'all remember what this word's called? That is the, start with the V, variance. That's the variance. That's the variance. Notice it says S squared out there. That's the variance, okay? It's important to know that because they could possibly give you the variance and ask you for the standard deviation. So you would simply punch in 85.9 and take the square root of it. Okay, that's a very possible thing. Now, to find that standard deviation, we take the square root of both sides, and we take the square root of both sides, and we'll get that 9.27 degrees, because that's the average distance away from the mean of the slope in angles of the whatever the heck we were doing. I don't remember. Bless. A bunch of pencils have pretty much slowed down. Any questions about that? I know it's a bunch of numbers. Your calculator will find the standard deviation like that without doing all this stuff. Don't do all this stuff if you have to, but I just think it's important that you know what your calculator is doing. But if you don't, it's okay. You better know that this is the what? Oh, that's the sample variance. I'm sorry, I said that. This is a sample standard deviation. We already said that. That's important. Interpret that number. The typical distance, the average distance from the mean of whatever the mean was. I don't remember. What was the mean? 38.5? The average distance away from 38.5, the values are varies by about 2.927 degrees. Typically varies 9.27 degrees from the mean. You gotta mention from the mean. You gotta mention typically varies, or on the average, it typically deviates. You could use deviates if you don't like the word varies. It deviates about the mean on the average of 9.27. And again, guys, there's 27 of you cats in here, and you can say it 27 different ways, and every one of you got a correct interpretation. But I promise you, you got to have from the mean, and you got to have something about what it's doing. You will have that on the test. Interpret this value. Interpret this value. Interpretation says you understand what it is, what you have done. Finding it doesn't understand anything about statistics other than you just know how to do some math. And I told you already, this is not a math class. How are we doing? 44. What time? 19? 18? 19? I'm going good. I know I put you guys a little fast, but I don't want to bog you down with boring stuff. I want to get through it. Okay, let me back up. I'm going to go through it again. Maybe we get the aha moment, right? So, standard deviation, there's the formula. That formula is on your formula sheet. I don't think you'll ever use it. Most of the time, they're going to give you the standard deviation. They're going to go ahead and give it to you. That way, everybody has the same answer. You don't have to find it. Now, sometimes they give you the variance. You have to find it, but that doesn't take a whole lot of work. So the first thing we had to do is find X bar. Once we found X bar, we found 38.8. I had to subtract that from each of those values to find a deviation. Here's a deviation, here's a deviation, here's a deviation, and I had to find all 6 deviations. Thank goodness I didn't have 30 sets of data. A lot of work, right? Boy, I used to be so mean to my students. I made them do it all by hand. I didn't tell them the calculator did it. We had to square those bad boys. If I don't square them, then this adds up to 0 every time. So we square all those values. Why? Somebody a whole lot smarter than us figured that out. Technically, because you can undo a square. Bless you. So you add all those up because that's what the formula says. Sum all those up. And once you sum all those up and you divide it by n minus 1 and not n, you would divide it by n if you knew the population. You would divide by n if you knew the population. But if you knew the population, there's no reason to figure out what the deviation of the population is. So sample, just think about it, right? If there's 30 students in here and you divide it by 30, you're going to get some number. If I divide it by 29, is that number bigger or smaller? If you divide by a smaller number, that makes this number over here bigger. But not by much, right? I mean, 30 to 29, and you're not going to change it a whole lot. But that just gives me a little bit more, because that's a sample. And so we're accounting for some variability. I'm sorry, for some error in my sampling. It's really the It's kind of my error in my sampling. Why did they choose 1? Yeah, who knows? I mean, if I have a sample of 1,000, the difference between 1,000 and 999 is no different. I'm not going to notice that difference. Okay, clicky, click, 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 click. Oh, the first number I find is the variance. If I take the square root of it, I'll find the standard deviation. It's possible they give you the standard deviation and ask you for the variance. Just make sure you understand the difference between those two. Variance is squared of the standard deviation. When you take the square root, you're really supposed to do positive or negative, but there's no such thing as a negative standard deviation because it's a distance. Yay. Question. Boom, 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 boom. Let me give you properties of the standard deviation. All these you should understand already, especially you mathematical people. S is always greater than or equal to 0. Always. Because you have some negative deviations, you have some positive deviations, but you square all those deviations and you make a bunch of positive numbers. So S will always be greater than 0. Can S equal 0? If S equals 0, what does that mean? All values must be the same because the average distance from the mean is 0. Therefore, all the values must be that. Good AP type question, right? Okay, that means do you understand what that means? Okay. This is from the Duh factory. A greater variation results in a larger value of S. Duh. I mean, the bigger S is, the greater the variation is, the greater the average distance from the mean is. I meant to go back for just a second. Darn gummit. Let me go back for just a second. 9. Let's talk about that 9.27, right? Is that a big number or a small number? It kind of depends on my data. What was the mean? 38, right? 38. So 9 from 38. If the mean was 1,000, now look at that 9 compared to that 1,000, right? You got 1,000 right here and you're deviating 9. Y'all follow me? So you can't say if 9's a big deviation or a small deviation until you kind of know what the data looks like. You have to kind of know what the center is. If the center is 200 million and you're deviating 9, whoo, that's real tight. 38, now you're deviating a little bit more. If my mean was 9, I'm deviating a bunch because I'm averaging 9 to the right and 9 to the left. I'm deviating a whole lot. I'm almost getting to 0. In fact, I'm getting below 0, which is really crazy. Y'all kind of follow all that stuff? Okay, I meant to say that earlier. Good, we did the second one. Here's the third one. S is not resistant. If you add an outlier, guess what? You have a really big deviation. And if you have a really big deviation, whoo, now what are you doing to that really big deviation? You're squaring it. Boom, now you made a really, really big deviation. So it's even less robust than when the X bar happens. Okay, because it amplifies it even more. You don't have to know all that. You just need to know that it's not resistant. Okay? So what things are not resistant? Standard deviation and mean, which those kind of go together. And the other two are the range and the, am I doing that backwards? I'm doing that backwards. Range is also range. Standard deviation, range, mean, median. That's all we got right now. Okay, click. One more. S measures variation about the mean. Again, that's the definition of what standard deviation is. It measures the variation about the mean. It should only be used when we report the mean for the center. Don't use, or let me rephrase, don't. You shouldn't use standard deviation with median. You shouldn't. I'm not saying it's right. I'm not saying it's wrong. You just shouldn't. Kind of think about this. What did you have to find in order to get the standard deviation? The mean. You had to have the mean in order to find the standard deviation. Therefore, you should use the two hand in hand. Again, I think these are really common sense type stuff, but I want to make sure that it's all kind of tied in together. Your calculator will do it as one step. Desmos will do it as one step. Not only will it do it as one step, most of the time they're going to give it to you. I just think it's important to know where it came from. They're going to give you the mean. They're going to give you the standard deviation. They're going to give you the median. They're going to give you the range. They're going to give you most of those numbers. They really are going to give them to you. It's your job to figure out what those numbers are telling me, where they came from, and more importantly, how to interpret them. That says you understand statistics. You finding those numbers says you understand the mathematics, and two different things. Doodling pencils. Okay, IQR. Is this the last one we got to talk about, right? IQR. This is where I'm going to mess your notes up. I'm going to skip some stuff, so make sure you ask questions of what you think you might need, okay? You can avoid the impact of extreme values in our measure of variability by focusing on the middle part of the distribution. Because if you focus on the middle, then you're not worried about what? Those outliers, okay? So here I'm going to look at quartiles. Quart. Divide things up into fourths. Divide it up into fourths. So I'm going to tell you really quickly. The first quartile, this is going to skip some of your notes, guys. Just bear with me. I think the part I'm skipping is okay if you understand this. Q1 is the median of the first half. So apparently we found what? The median of the data, and then we found the median of the first half. That's Q1, the first quartile. Q3 is the median of the second half. Q1 is from the first half. Q3 is from the second half. And somebody's going to go, why did they go 1 to 3? What happened to 2? That's the median. Most of you guys understand that, but there may be one or two thinking, what the heck, right? And then there's going to be some knucklehead, wait a second, if it divided into fourths, why do I just have 3 numbers? 2, 3, 4. Median of the first half, median of the overall, median of the last half. This is the first 25%. This is the second 25%. Here's the third 25%. And then this is the fourth 25%, which accounts for 100%. The IQR is Q3 minus Q1. IQR, again, I skipped some stuff on your notes, ladies and gentlemen. The IQR is Q3 minus Q1, which accounts for what percent? The middle 50%. We're leaving off the far left 25 and the far right 25, and we're focused on the middle 50%. Just like range, the IQR is one number. It's Q3 minus Q1 because it's always positive. Well, I did Q1 minus Q3 and got a negative. Well, freaking just put a plus sign with it. Change it. It's not negative. Okay, I skipped some stuff. Looking through your notes, what word do you need that you skip through the notes that you're concerned about? Quartiles. Divides it up into fourths with 3 numbers. Q1, Q3, and Q2. And if you don't like to write the word median, guys, there's you a variable Q2. Q2 is. Except I like the word median better because that sounds better. that's really not a variable, but it's not wrong. Let me go back. Here I have a set of data. Here's the median, 28 and 29, 28.5. I split it in half. Now I need the median here, 22 and 25. And then I need the median over here, 31 and 34. Y'all okay? This one is Q1, this one is Q3. And it's about this time where somebody says, what if it's an odd number? Oh, catamarans are boats built with two hulls. If anybody wants to know anything about a catamaran, I'll tell you. I was on one for 10 days in the Virgin Islands. Me, my bride, 4 other couples, my friends, the captain and his wife. And the captain's wife was our cook. 10 days, floating around the Virgin Islands. I hate you guys. Okay. Certain catamarans are built to withstand often rough passage across open waters. That didn't happen in the Virgin Islands. One important characteristic of these boats is the freshwater capacity, measured in gallons, to accommodate the daily water use by those on board. The daily water use by those on board is really impressive because there's a whole bunch of unlimited supply of water underneath it, except it's salt water. But they have little things that clear all that out and make you fresh water. It's pretty cool. Anyway, find the interquartile range. Here we go. There's 158. What am I going to do with the 158? Split it into 2 numbers. No, you idiot. You split this into 2 numbers, and these are 2 numbers down here. Now you change the whole set of data. Put the 15 on this side and the 8.5 on this side. No, you're really an idiot. You just forget about it. Don't worry about it. Just drop it. You're dropping a data point? I don't know what else to do with it. I can't put one on one side and one on the other side. Then I'm adding a data point. I'm better off dropping it and not counting it rather than I'm making up data. So then I'm going to find the median here, and I'm going to find the median there. And like I said, you don't worry about the 158 in the middle. Everybody okay with that? And so you find this number out here, which is, or that one over there, which is 206, and this one over here, which is 145, and you subtract and you get 61 gallons of water. How would we interpret the interquartile range from example 3? How are you going to interpret the interquartile range? Interpretations are going to be huge. At the end of the year, I'm going to give you a sheet of paper with interpretations. You know 2 right now. Actually, you know a couple others, but you know them to be so common sense. But the IQR is the middle 50% of the data. The middle 50%. The middle half. Ooh, they like half. Okay, whatever. The middle half of the distribution in the 19 ocean-going catamarans has a range of 61 gallons of water. They're talking about the middle half, the middle 50%, whatever it might be. Let me ask you this. It may come up in just a second. IQR resistant or not resistant? Is it affected by outliers? So it is resistant. So the 2 things that are resistant are the IQR and the median. It's ironic. If you report the median, you should report the IQR. If you report the median, you should report the IQR. All right, I talked a lot right there without really making you write something down. How are the notes? Yes, no, maybe? Do I need to revamp the whole notes or? My bet is next year's book is going to be a whole lot smaller than this one. I like my slides. I think they're going okay. Oh, there it is. They are resistant. Okay, they are resistant. Boom, boom, boom. If odd, be sure to leave out the median. Okay, So let's make sure you understand this because this is a kind of a big deal, right? Which measures of center and variability should we use to summarize the data? Right? We know we need the shape, we know we need the center, we know we need the spread. Which ones should you use? Well, it's going to depend on the shape. It's going to depend on the shape. If it's symmetric, we like to use the mean and the standard deviation. Okay? If it's symmetric, we like to use the mean and the standard deviation. I just did that backwards, I'm sorry. But if it's skewed, we like to use the median and the interquartile range because they're not affected by those outliers. Okay? So if it's skewed or has outliers, we'd like to use the median and the interquartile range or the IQR. If it's symmetric, we want to go ahead and use the mean and the standard deviation. You should never use the mean with the IQR, and you shouldn't use the median with the standard deviation. There's not wrong. If you want to talk about shape, center, and spread, you're going to get the points because you talked about the shape and the center and the spread. The book is going to ask you which one should you use. Okay. What do you think? Yeah? Dang right. Cool. Click. What are we going to use for this one? Mean and standard deviation. That's pretty symmetric. This one, median, IQR. They're not going to make it difficult. Well, I don't really know. Well, then use one. It doesn't matter. Click, click. According to recent estimates, approximately 20,000 black bears live in Pennsylvania. Here are the summary statistics. There it is. Which measures of center and variability should we use? Mean, standard deviation. Look, notice over here. This is very, very common. I apologize for you guys. If I realized this at the time, I would have put it up higher. In 97, that tells me what? 97 samples, 97 bears. Mean, 60. What was it in? Oh, that's the length. They're average 60 inches tall. Yeah. With the standard deviation of 10. There's the minimum of 36. There's the quartile 1. There's the median. There's quartile 3. And there's the max. And that's really, really common. They give you that stuff. It's your job to take the information from that and put it into something useful. Somebody else is going to do this part for you. You're the statistician. You got to know what to do with these numbers. Click, 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 click. I hope you can find the median. I hope you can find the mean. I hope you can find the range. I hope you can find and interpret the standard deviation. I hope that you can find the interquartile range and interpret it. And I hope you can choose the appropriate method. Let me show you one thing while I have time really quickly. Oh, you guys got time. Good. Oh, come on. Get out of that image. Here we go. Here's this stupid thing called a calculator. Let me show you because you may have to do some things on your homework that I don't want you to do by hand. Some teachers are mean. They'll make you do it by hand. I'm not going to do that. I told you we got this button right here called stat button we're going to wear out. So whatever your data is, put it in there. Stat edit. Stat edit. Put it in there. I like to always put everything in L1. What if I have something in L1? Overwrite it. Delete it. Don't delete L1. If you delete L1, set up editor. The quickest way to clear one, bless. Oh, I forgot. Dang, that's been a while. That's been a while. You're good, man. All right. I forgot. Stat, clear list. 4. You just have to tell it which one to clear. Tell it which one to clear. If you want to clear L3, clear L3. If you want to clear all of them, second plus. Clear all lists. That clears them all. If you don't have to clear them, you can overwrite them. Stat edit. If this is wrong, we can put 52. Whoops, it didn't go. 52. If I don't need that one, I can delete that 1. Right? 54, 51, 34, good enough. Stat, it's in there forever until you delete it. It's in there forever until you delete it. Now, stat, now I don't care about editing it. You could sort it ascending if you really wanted to. Who cares? You could sort it descending, but you don't have to. You can clear the list and you can set up the editor. You should be comfortable with that. Calc, one variable stats. That's the statistics for one variable. Just put one variable in. That's what I want. Enter. Anybody have an older 83? I forgot to fix that, but older 83, you're just going to hit stat. Does yours do this? Does it ask the same thing? I think you're probably okay. L1 is where my list comes from. If you put it in L2, then change it to L2. And if you put it in L3, change it to L3. And frequency, how many times it occurs. And I just leave it blank. But if you want to put a 1 there, I think you can. And then calculate, boom, enter. Looky, looky, looky. It gives me the what? The mean, X bar. The little summation of x's. So if I add all those x's up, I'm going to get 206. And guess what? If I take those 206 and divide it by 5, I'm going to get 41.2. And if I take 206 and I square 206, I'm going to get that. And I don't have any idea what that's for. And right below that, you see what? S of x, which is the standard deviation. Ooh, my fault. I did not tell you this. So this is the sample standard deviation. This is the population standard deviation. This one was divided by n minus 1. This was divided by n. That's why this one is bigger than this one. So if it was the population, you would use this, but you hardly ever have the population. You only have samples. And if you go down further, oh, that's right here, sorry. There's the minimum. Here's the Q1. There's the median. There's Q3, and there's the max. Your calculator is going to give you everything. It's your job to tell me what we're supposed to do with it. I think your homework is posted. I got it due Tuesday. 9, you got 10 minutes. That's enough to get good start.